Hello, and welcome to our session. Today, we're going to speak about how BigID can incorporate and work on top of a Databricks environment in order to help identify sensitive data elements that might exist on top of the data that sits on Databricks, right? Some of the key points or reasons why you might want to do this is just to make sure that there are no sensitive data elements that your data scientists might not have access to or shouldn't have access to. And you just want to know, right? You just want to be able to scan your data, have an understanding of what exists inside of that specific data repositories that are connected to your Databricks environment. And you can do that with BigID. So BigID is a user interface in a technology stack that allows you to have a good understanding of what exists contextually inside of your data environments. And Databricks is a data repository that BigID can connect to and certainly understand. BigID's core capabilities started out in data discovery. So just being able to learn and understand what types of data elements exist across your data landscape. And that's the discovery in depth data insights that BigID provides. And that's one of the 4C foundations that BigID has within its framework. The discovery foundations that we have are the classification, which allows us to classify when we find sensitive data elements using machine learning as well as regular expressions and looking at metadata as well as data itself. We have another technology called correlation, which helps to learn important identifiers across your data landscape to teach itself via using the machine learning techniques to understand where that IDs exists across your data landscape, as well as other learnings on top of what we see in relation, close proximity to that specific identifiers that you teach us about. We can also look at your data and leveraging regular expression pattern matching to detect where things are. And we can also cluster using machine learning to teach you where like elements exist across your data landscape, right? On top of this core stack, that's the framework that we have within BigID, the 4Cs. On top of that, we can then action on top of the data itself. We have a framework that allows for apps to be built for the mindset of privacy, protection, and perspective. And these apps are built by our own developers internally, by some of the field resources, by some of our partners and the customers themselves, right? We have SDKs and APIs that allows for people to go ahead and build their own business requirements or business software on top of our 4C foundation that BigID has inside of our data discovery in depth. And the last thing is just the ability to unleash your data, right? Based off of the core findings, based off of your ability to action on top of your data, we are providing this global data access and virtualization to be able to provide you with a complete understanding from a privacy standpoint and protection standpoint of your data holistically. So you can really start to take action on top of everything that is found inside of the BigID discovery platform. In terms of the Data Discovery Intelligence Foundation, I already kind of got into them on the last slide, but knowing your data, knowing exactly what exists on top of your environment and understanding of your crown jewels. So on the left-hand side, it shows a representation of all the different data sources that BigID can connect to. And if we're connecting to something like an RDBMS, typically it's the JDBC connection. If we're connecting to applications like an Informix or a Salesforce, a lot of times BigID just writes to the native APIs. And if we're connecting to things like SMB, Samba, or any kind of NFS type of shares, we're also connecting using the native protocols that are available with those different data repositories. On top of that, once BigID has the connection information to these different data repositories, and today there's over like 130 data sources that we can connect to. As you see here, Databricks is one of them. We can then classify your data. We represent the classification of all your data on top of a catalog. We do the cluster analysis and the correlation, as I mentioned before, right? So using several techniques to help understand what you have on top of those data repositories so that you can start taking action on it. You could adhere to different policies. You can start leveraging the applications that we've already pre-built or building your own. And then when you look at the foundation, this is the layer that we provide our data discovery in depth. And it is important to know it can be deployed on the cloud, on-prem, a combination of hybrid. It can also work with data in motion, like your Kafkas or your Kinesises. We have the applications that sit on top of it, and we have applications already pre-built that you can certainly use today, such as your privacy apps. Maybe you want to just look for PI inventory or sensitive data element inventory. You can look for DSAR fulfillments, so you can execute DSAR requests on top of our foundation. You can look for different access intelligence, so you can have an understanding of what data elements exist across your landscape. We have remediation, that's in the protection as well. We have ability to label data, and we can incorporate with other third-party vendors for that in addition, as well as our own labeling. And we have data perspective apps like your retention management, and that co-links with your remediation. So if you have retention policies where you have to maintain data for 7 years, and you have a remediation app that needs to purge data, those two go hand in glove to know, hey, I'm trying to remediate something that is also part of a retention policy, right? We have also data lineage type of applications as well that help with the data landscape, where things came from, where it's going, and additional things in terms of that. And then from the joint value between the two solutions with BigID and Databricks is just the fact that customers can now have a complete understanding of everything that is on top of their data landscape, from Databricks, anything that lives in maybe in Spark on top of Hadoop, any technology within RDBMSs, file shares, and just be able to say, hey, there are sensitive data elements inside of this repository. Now, who should have access to those? And be able to start even showing insights to what group of users have access to it, and just knowing your data, right? And once you know your data, you can start putting governance around that to make sure that you're doing the right security ramifications on top of that sensitive data for your data scientists to start to really use appropriately, right? And that's really the glue between what BigID provides and well as, on top of the Databricks stack itself. So let's jump right into a demonstration here. Just want to kind of give you a lay of the land. I have a Databricks environment here. Inside of my Databricks environment, I have a cluster, this test cluster. Inside of my test cluster, I've got some data here. Inside this default database, you can see a list of all these different tables that exist currently. Some of these tables have sensitive data, some of them do not. It's not very large data, but it's enough to kind of show exactly the power of what BigID can provide. So this is our Databricks environment. And now let's go ahead and look at the BigID environment. When I first log into BigID, I'm prompted with a username and password. This username and password can be easily incorporated with LDAP to AD, for your user credentials to be stored and managed by a central management system that you folks have. It can be incorporated with SAML, even SSO. Right now, I only have a single data source here. I can certainly configure just a bunch of them, and I'll show you how to do that. And this provides me a map of all the things that we are showing inside this environment. Again, just a single data source. And it shows you the attributes found. So these attributes would be classifiers or classifications that we enabled within BigID. So when we do start to expose or find context inside the data sources that we're scanning, they'll be flagged here, right? And if I configure any policies like GDPR or CCPA, they'd show here. And if I configure correlation sets, now correlation sets is like a mechanism for us to, you can teach BigID about identifiers that are important for my business and it's important for BigID to know. Think of like an identifier, like a customer ID, account ID, some kind of a GUID or something that helps represent something like a product SKU. And once you teach us about this, we help show you where those identifiers exist across your landscape and any relation that identifier has with other things that we see contextually around that identifier. You can see the objectable findings. So I'm going to just go ahead and jump straight into how to configure a data repository, focusing completely on a Databricks. I already have one here, but I want to go ahead and create another one. So here are all the different data sources that we can connect to. There's a lot of them. And you can notice Spark down here, but we also have one specifically for Databricks. And now I can select this. We'll go ahead and give it a data source name. And I'll say yes, enabled. And now I'm going to give it the location for the Databricks environment. Let's go ahead and give it information pertaining to the connection details and the username and password. Okay. So from here, I'll go ahead and move on to the next tab. And if I want, I can associate a specific business owner, an IT owner. This would help me from an understanding of like who manages this specific data repository from a business user as well as from an IT standpoint. I can provide a location information if I want to and additional details. And then I can say if I want to do sample scans, if I want to do full scans, if I want to enable classifiers, enable enrichments. So classifiers will say, yes, I want to go ahead and classify data as I scan it. And I'll go ahead and save this at this point. And let's go ahead and now test that connection and see if we could establish a connection to this Databricks environment. Great. And once it tests connection successfully, you can see a list of some of the tables that show up here, right? ID list Parquet, different types, customer 2, Oracle CSV. So if I look back at my Databricks environment, my clusters, yep, here's the Oracle CSV. So we can see that we are connected to the right environment and the test connection worked great. And we can go ahead and move on to the next step. So within BigID, here are the 4 C's that we were talking about before, the catalog, classification, cluster analysis, and correlation. When we start scanning your environments, we are providing all the findings inside of the catalog so you can easily hone in on specifically what we find, right? So you can do quick filters for contains PI, which would be sensitive data, has duplicates. So when we look at unstructured repositories as well as structured repositories, we can start showing you that there are duplicate sources across the data landscape. Maybe you have duplicate tables that were part of an ETL job that came from Oracle and that got copied up into Databricks or something to that extent, but the has duplicates will help you identify that. I can hone in specifically and filter out based on the data sources. I can also filter based off of attributes, right? And then these attributes are basically the classifiers. You can see classifier dot public IPv4. So, you know, it looks like it, if I click on this, it'll filter out a specific data table inside of this Databricks environment has the classifier public IPv4 identified in it. So from a management of the classifications, we have this gear here that can help us to toggle on different classifications. Now, as I was mentioning before, there's a few different flavors for us to, within BigID, to scan your data environments. We can leverage techniques such as machine learning. We can leverage regular expression. And these top 15 or so before this first line break are all our supervised machine learnings to understand different documents. We've already pre-taught our machine learning algorithms what context makes up that of a boarding pass, what makes up that of a criminal record check, CV check, and the machine starts to learn based on us teaching it, and we can then apply that learning across the data landscape for you. What's great is you can also train BigID on the document types and document elements that are important to your business, right? So just by having BigID look at a sample of like 25 to 50 documents of X type that's important for you folks for BigID to learn, we can teach BigID this, and then we can start applying that learning across your data landscape so we can classify that document of being this type, right? And these are the ones that are pre-taught for you out of the box. We also have this named entity recognition to help identify country, city, full name, and phone. And this uses an unsupervised machine learning approach to detecting phones and names and countries, right? Which is super difficult to do. if you're trying to do like a regular expression, it's just better to use a machine for the identification of that. And we also have now the last line break here, all the different regular expression pattern matchings that you can have, right? Inside of our regular expression pattern matching, it's not just a pattern match, but we can also do things like a checksum validation. We can also have a support term regular expression. So if we match this pattern of a credit card and it's in this min length, max length, and when it does a checksum validation with this loon checksum validation, we can also have a support term regular expression that says, all right, I found this specific pattern. It looks like it matches that of a credit card. It matched it passed the loon check. We can also have it look for another supporting regular expression. So say, for example, if a credit card number, I might have a CVV or I might have an expiration date. So I can look for a support term with proximity, how many characters before and after this match would I expect to see the expiration date as an example, right? So it helps with the false positives with just a traditional regular expression. So these are all the classifiers, and you can see the ones that I have enabled in this environment. So now from here, I can actually go ahead and execute a scan. So inside of the scan profile, I can say, all right, I have my data source I created. I made the connection to Databricks. I can now create a Databricks environment profile. And from here, I can specify the scan type. There's different categories of scanning. I can do just a linear scan, a data source scan, a metadata scan, which just looks at your higher level table names, your file names. I can do a hyperscan, which does a quick scanning using a combination of a percentage of data plus metadata to help you identify things. So if on unstructured repository, so say if you have petabyte scale data, it could take a while to scan. So hyperscan reduces that down drastically to make it more palatable, so that it gives you a good understanding of what exists inside of it super quick. And then from there, you can make a determination how much deeper of a scan you want to do. You have a schedule, so we can execute the scan automatically for you on a regular basis. And then I can specify correlation sets. We haven't showed you anything and talked about correlation sets yet, but a correlation set, like I was mentioning earlier during the PowerPoint slide, you can specify within BigID the identifiers that are important to your business. And then we learn about those IDs and we understand where they exist across your data landscape. And then from here, I can just say, go ahead, let's go ahead and I'm not going to select any correlation sets here because we don't have any defined. I'm gonna select this data source one that we created, which was a Databricks data source. I'm going to go ahead and save this. And now I can go ahead and run it. Right, and so once I run this, it's going to start queuing up and it's going to start running, and you'll see it can proceed. So in the interest of time, this should only take a few minutes, but I'd rather just jump straight to the catalog, and now we can show you what we've uncovered and the data that sits inside of this Databricks environment. So we have this Databricks. We have here are all the different objects that we scanned within this environment. I can hone in specifically on what contains PI. Now I can actually click on this specific table, this events table that you saw that was right here. I can say, okay, it looks like this does have sensitive data elements as I filtered things out. As I start clicking, you notice I start building this query string on the right-hand side. Everything that I show you within the UI can certainly be surfaced via REST APIs, etc. I can add tags. I can actually pull tags in if this was, had tags created via like another solution like MIP or another metadata labeling solution that's available. It gives you information about details when the last time it was scanned, created. I can look at the attributes. Here are the classifiers that have been identified in this specific repository. I can now click on this. I can get attribute value, which will give me a sampling, assuming that I have the proper role-based access control within BigID to show me, oh, this is why it was cataloged as or classified as a US Social Security number, because it did find this specific element inside this table here in this specific column. I can actually look at the column names, click on the column names, and get profiling information for this, which is always good for your data scientists to understand, well, what is the makeup of this specific table? What kind of profiling is inside this table itself? Right? And you can see the classifiers that have been identified for this specific column, right? So again, just a fantastic way for BigID to be used to help discover what is inside this data before you start having your data scientists really start building machine learning models on top of it, right? Knowing what's there first, having profiling information, having quality information, having maybe users, some data scientists should not have access to different elements that make up this specific data repository. Maybe the data element should be masked and it's not, right? It's in clear text. So all this information is pertinent to know before your data scientists start to actually use it. And it can also be used by your data scientists to understand your profiling information of what makes up the actual data itself. From here, we have other things as well, like cluster analysis and correlation. I'm actually going to go to another environment to show you folks more insights into what BigID can also do in addition that has just more information inside of our demo environment. So if I go over to our cluster analysis, you can see inside of here, what we basically do is when we scan your unstructured data repositories, we can start to build clustered of like information, like contextual information, right? So each one of these circles represents a cluster, and it's all based off of distance. Like the further away these clusters are, the more unrelated they are, the closer they are, the more related they are. And then if I click inside of one of these clusters, it tells me the top keywords that make up the cluster. Think like a K means nearest neighbor machine learning model. I can get all the lists of attributes that have been identified in this specific cluster. I can see the objects per data source, the number of duplicate files inside of this cluster as well. I can even then click on the object. I can see that there's 30 objects that are represented inside of this cluster. Some of them have open access, meaning everyone full control, and you can even define what open access really means in your world. It doesn't always have to be everyone full control. It can just be these group members have access to this specific data, right? And you can see where they exist, from Office 365 OneDrive to NFS shares to SharePoint Online. I can take this, export them, but very similar to what we saw before with your catalog, you can get information for it this way. I can look at the attributes. I can click on this classifier country. I can get attribute values. It's going to fetch the values that made this attribute or this classifier get triggered. And you can see it looks like it found Ireland here, right? I can preview the data as well. So this actually takes a connection back to the source. So BigID doesn't store the data. BigID establishes or reestablishes a connection to the source where this file exists, and it pulls it into cache, a caching layer, and then it represents what it found. And that's why it'll highlight it. And I can hover over it and it'll tell me, oh, that matched the country. This matches a street number. This matches an email address. Right? So we have related information this way. And now I can click on duplicates and show you all the duplicate files that have been found that are closely related to this file, right? If they're not exactly the same. So that's what cluster analysis does. And then on top of this, we also have correlation. And now correlation is able to go even a step further on the structure side of the house. If I select an attribute like an email, you can see on the right-hand side, it looks like email was found 17 times across 17 different tables. So if I expand out these tables, I can select them, and it starts to build you a map of how things are interrelated to one another. So based off this email attribute that we selected, there's a 91% probability or confidence level that this email attribute matches its email underscore address in this transactions table. A 97% probability that matches this email in the security table. And it doesn't always have to be email. Like see this one right here. This is a notes table, and it is finding email inside the comments field of a notes table. The also additionally interesting thing to note here is, like, you'll notice that it also pulled in this transaction table from this linkage database based off this transaction number. So what it's basically saying is that every single time an email address is identified, there's a close proximity to this transaction number that's also identified and it's related to this transactions table. So we figure we just enrich some of the findings with something else that we found that you might not have known about before by showing you this graphing of how things are interrelated. So it's a fantastic way to understand where, like email addresses, like customer IDs, like product SKUs, where it exists across your data landscape where you might not have known it exists before, as well as building relationships that you did not know about by having that linkage to other elements such as that transaction number. So those are basically the 4 C's, the foundation in depth. And then on top of that, we have applications, right? So your applications cut across your data privacy, your data protection, and your data perspective, right? So like I was mentioning before, you got the data rights fulfillment, that's their DSAR requests. You have things such as access intelligence, you have remediation, and you have data retention. So BigID, to wrap up in summation, is a fantastic mechanism to discovering all your data elements across your data landscapes, whether it's on top of Databricks, NFS, SMB, whether it's your applications like Salesforce, SAP. BigID helps with the understanding of everything that is across your data landscape. It then helps to showcase our findings or BigID's findings with the catalog. And then you can start building your applications that are, or using applications that we've already pre-built for your business needs, whether it's DSAR fulfillment, whether it's access intelligence, whether it's remediation, retention, etc. So I hope this session was informative to you. Databricks has been a great sponsor, or Databricks has just been a great technology to work with from our standpoint, especially on the machine learning front. And we hope to meet with you in the future to do a deeper dive on any one of these areas that are of interest to you. Thank you very much and take care.